Welcome back to The Explainer. So today we're going to look at something really fascinating. We're actually stepping into a totally unexpected setting to do it, a grand Victorian library right in the heart of London. Picture it, a place where craftsmanship is literally everything and flawless quality is just the unspoken rule. Now we're using this gorgeous analog library as a metaphor to break down the highly technical mechanics of safely rolling out AI models on Azure. I know, it sounds like a massive contrast, right? But trust me, this little story hits the nail on the head when it comes to the real-world nuances of modern AI deployments.
Let's jump right in with a pretty wild question. How exactly do you test the soul of an AI? To figure this out, we've got two protagonists. There's Margaret, she's our senior software engineer, and Timothy, her junior colleague. Now, for weeks, their library had been absolutely slammed, peak capacity, and their automated safety guardrails, completely silent. No red flags at all. But Timothy noticed something. The code wasn't breaking, but the vibe was definitely shifting. The answers their AI librarian was giving readers were getting shorter, a bit more clinical. They were completely losing that warm, helpful touch they were famous for.
And Timothy brings up a brilliant point here. He tells Margaret, hey, nothing is actually broken, but something is definitely fading. You see, the AI model they'd pushed the night before, it passed every single unit test with flying colors. But readers were starting to complain. The AI was technically correct, but it was losing its soul. Timothy compares it to a slow gas leak that completely fails to trigger the fire alarm, which honestly is a terrifying scenario for any dev team. Your dashboards are all green, telling you everything is perfectly fine, while the actual user experience is just quietly deteriorating.
So, how do we actually go about detecting this subtle vibe shift?
What exactly is this invisible enemy creeping right past our guardrails? Margaret grabs a sharp cobalt blue marker to break it down for Timothy. She calls this phenomenon semantic drift. Now, standard tests, they're great at catching system crashes, right? They grab the syntax errors, the broken logic, the whole shebang. But Margaret points out that they completely miss this qualitative decay. It's when an AI starts spitting out answers that are factually okay, but stylistically or, qualitatively wrong for your specific use case.
It's a huge contrast between the old way of doing things and the reality of large language models. In traditional software, pass or fail logic, that was enough. With LLMs, pass-fail completely misses the decay. Margaret tells Timothy that if they want to protect the library's standards, they absolutely have to stop relying on hopeful deployment. Just tossing it into production and crossing your fingers. Instead, they need to shift to something she calls traffic shifting validation.
And that brings us right into the concept of the canary deployment. To visualize how this traffic shifting actually works, Margaret uses her cobalt marker to draw a tiny birdcage right at the library's entrance. We don't test it on everyone at once, she says. Instead, she maps out two paths, a massive, wide one and the super narrow one. That narrow path, that's the canary deployment. Whenever they update the AI model, they only route a tiny 5% of user traffic to it. Those are the canaries. The vast majority, the other 95% of the readers, they just keep using the older, stable model. And the team watches those canary interactions like hawks in real time. The absolute crucial point here is risk mitigation. Margaret explains that if the new version starts acting weird, if that 5% slice starts suffering from that semantic drift we talked about, they literally just kill the connection. Boom, done. And they do it before the other 95% of the library even realizes a change was made. It is an incredible, proactive shield against widespread user impact.
But we've got to measure this behavior against something, right? Enter the gold standard.
Timothy, being the sharp junior engineer he is, asks a really fantastic question. If the AI's answer is technically correct, how do we catch that vibe shift without manually reading every single response? That would take forever. So Margaret draws a little vault to explain her workaround. She reveals that the library actually curates a gold standard archive. It's basically a baseline of their absolute best, highest quality historical interactions. And here's the genius part. They don't measure every single breath the AI takes. They sample. The similarity scoring runs asynchronously in the background. The user never ever waits for the score to calculate. The system just checks it a second later. It calculates the mathematical distance between the canary's output and that gold standard. And if that distance grows too wide, Margaret says, the bird stops singing.
Okay, so how do we know when the new model is actually ready for the big leaks? Let's talk graduation rules. Once we have a canary out there singing along, how long does it have to survive before we can trust it with the whole library? Margaret sets a really strict graduation rule. She draws a timer and writes down a very specific number, 10,000. For the new model to officially graduate, it has to successfully process exactly 10,000 requests. And it's not just about volume, by the way, it's also about time.
Margaret's philosophy requires serious patience. The Canary has to stay in the green for a full 24 hours and hit those 10,000 requests. And even if it meets that threshold, they don't just blindly jump straight to 100%. No way. They shift the traffic incrementally, up to 25%, monitor, and eventually up to 100%. Her motto is basically, trust but verify, then trust just a little bit more. It's honestly a beautifully cautious way to handle scaling.
But what happens if things just completely go south? We need an emergency brake.
Timothy asks the ultimate pessimistic DevOps question, which, let's be real, is totally necessary. What if the rollback itself fails? What if the automated system just jams? You always have to plan for the worst-case scenario. Well, Margaret doesn't even flinch. She draws a second, much heavier lever, the emergency brake. It's basically a hardcore circuit breaker that kicks in if the automated rollback blows up. Instead of letting a broken AI talk to the readers, it instantly defaults to a safe, static, pre-written response the library is temporarily experiencing high volume.
And that brings us to a really foundational rule of system reliability. Margaret tells Timothy, look, it's not ideal, but the absolute worst outage is the one where the system lies about being fine. They call this philosophy the cobalt arc. They would much rather hang up a quiet closed sign than leave up a broken open sign. It is always, always better to gracefully halt the system than to confidently serve up degraded or toxic garbage to your users. So let's watch this all come together in practice. Timothy is glued to the dashboard as a new update rolls out. Just a few minutes in, step 1 triggers. The similarity score on that tiny 5% canary slice suddenly dips into the red. Before Timothy can even move his mouse, step 2, the automated cobalt lever flickers. And step 3, traffic instantly shifts right back to the previous stable version. The warm librarian's voice stays completely intact for the public. It happens so fast and so seamlessly that Timothy just exhales and realizes, wow, the readers didn't even notice a thing.
Margaret caps her marker and delivers the ultimate takeaway. Reliability isn't about never making a mistake, it's about making sure that your mistakes stay small, quiet, and far away from the front desk. As LLMs and AI models keep getting more complex and, frankly, more unpredictable, the question isn't really if your AI is going to experience a vibe shift, it's when. And when that day inevitably comes, are you going to be relying on hopeful deployment? Or will you have a canary in a birdcage ready to protect your users? Thanks so much for joining me on this explainer, and definitely stay curious out there.